Hello everyone, I hope all of you will be doing well. In this video, I'm going to model, analyze, and design a one-story RCC frame structure in ETABS, and we will start from creating the grid line and then modeling the whole structure, then analyzing and then designing the structure in ETABS. So first of all, before going into ETABS, we will go through the architectural drawings of the structure. So these are the architectural drawings. As you can see, this is a one-story frame structure, and these are all the rooms inside this building. So you can see the length of the structure is 96 feet and 4 inches, and the width of the structure is 36 feet and 9 inches, with different grid lines along the x-axis and as well as along the y-axis. So the first thing that we would do this to this drawing is we will clear it and only leave those parts that we need for our modeling. So I have already cleared the unnecessary. So let's go to the elevations of the building as well. This is the front elevation of the structure, and this is the side elevation of the structure. As you can see, the total height of the ground story is 10.5 feet, and that of the roof is 9.5 feet. So let's go to the cleared version of the drawing. So this is the cleared version. I have removed the unnecessary stuff from the drawing, so I'm only left with the walls, as you can see, and the necessary grades of the structure. So we have 11 grade points along the x-axis and 7 grade points along the y-axis with different spaces, distances. So this is the column layout. First thing that we would do to this drawing is that we would uh, locate the columns. So these are the columns that we have placed on this structure with the coordination or with coordinating with the architecture. So we will determine the orientation of the columns based on the longer distance of the span and as well as the loading conditions, and based on the architectural requirements as well. So after that, we have placed the plinth beams, and after the plinth beams, we are going to place the main beams. So let's go to ETABS and uh, create this grid line over there, and also draw the columns and beams in ETABS. So in ETABS, this is the interface of the ETABS. You will go to File and then select New Model. After selecting a new model, we will click on the Use Built-in settings. So we are going to choose the US customary system. You can use whatever system you like, the metric system or US customary. So since we use the feet and inches system here, so I would select the US customary. And for region or for default material, I will also select the United States. Steel section database, this is the correct version. For steel design code, this is also correct. And for concrete design code, since we have selected these two, specifically United States, so I'm going to select the ACI 31819. So we will click on OK. Now this window appears. So we are going to now create the grid line for our structure. You will select custom grid spacing, then we will go to edit grid lines data. So now this is the x-axis and this is for the y-axis. So we will click on the display grid data spacing. Why? Because this one uh, draws or the create each grid line with the reference point of the start or the zero. So as you go from zero to the first grid, so you will enter, for example, 5 feet, and to the next one you will add that 5 feet. But for this one, we are going to only enter the spacing between the two grid lines. So coming to the AutoCAD back, so as you can see, we will first draw the x-axis grid lines. So from we have 11 grid points. So let me enter all of them. Okay, I will enter one by one. So this is my, since on x-axis in AutoCAD we have it as 1, and on y-axis we have it as a b c, so on. So we will change this nomenclature on x-axis to 1. So we will check out the distance. It is, as you can see, 1 to 2, it is 4 feet 1 inches. 4 feet and 1 inch. 4 feet and 1. For second one, let me add more points, more grid points. So now for second one, we have 7 feet 11 inches. For third point, we have it 11 feet and 9 inches. For fourth point, we have it again 11 feet and 9 inches. For fifth point, we have it as 9 feet 9 inches. For sixth point, we have it as 11 feet and 3 inches. 11 feet and 3 inches. For point number 7, we have it as 17 feet and 9 inches. For point number 8, we have it as for point number 8, we have it as 9 feet. For point 9, we have it as 5 feet and 11 inches. For point 10, we have it as 7 feet and 1 inches. I think it was 7 feet and 1 inch. 7 feet and 1 inch. And for point 11, we have it as 0. Okay, so I will delete the extra points I have added. So now coming to the y-axis. In y-axis, we have the nomenclature as A, B, C, D. So I will add 7 points. Okay, so A. Now I'm not going to start from A, because as you can see in here, the spacing is being started from this lower point, from 0, 0. So in this grid line system, we have G as the 0, 0, and then going upwards, reaching towards A. So I would start from G. So the first distance is 7 feet 7 inches. 7 feet and 7 inches. The next grid point is F. So for F, we have the distance as 7 feet and 11 inches. And then we have grade point E, and the distance for grade point E is 5 feet 9 inches. 5 feet and 9 inches. And then we have got D, and for D, as you can see, the distance for D is 2 feet. So for D, we have got the distance as 2 feet. So then we have got grade point C, and the distance for it, as you can see, is 1 feet. So we have got C, and then the distance is 1 feet. Let me draw the feet. All that is already feet. So then for point B, we have 12 feet 6 inches. For point B, 12.5 feet also. You can write, oh, I'm sorry. Point B, 12.5 feet. Okay. Then we have got grid point A, and the distance for A is 0. We will click on OK. Now for story data, you click on custom story data. Then we will delete only this one story. Right? This is gonna be deleted. Okay. So for this one, this is plinth level, because we are going to add plinth beam, plinth level. Okay. This is ground story, and this is the upper story. Okay, so this is the elevation for this one, we will take it as 5 feet. For this one, we will take it as 10.5 feet, as we saw previously earlier. And for the upper story, we have got as 9.5 feet. Okay, so now we have created the grid lines. So we will wait for it to appear. Okay, so now this is the 3D of the grid line, and this is the 2D. So now everything is now coming towards to ETABS. So we will model and place each column that you can see in this grid line and each beam correctly in this ETABS model. So for ETABS, we will first define our material properties. So we will add new material. This is correct, 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 and we will only change the grade. So let me add new material. Okay, we will add concrete. Okay, so this is 3000 psi. I would like to add 3 KSI concrete. Okay, 3 KSI. Okay, everything is correct. This is correct. Mass is also correct. This is the modulus of elasticity, Poisson's ratio, coefficient of thermal. So take everything as it is. Just click on OK. Okay. So now then we will define our section properties. So let's check our AutoCAD and check out the sizes. We have C1, C2. Uh, then okay, let's check out each column and take out sample of each column. And I think this would be more beneficial. Okay, let me clear these up. So now you have got C1, okay, C2, okay, we have got C4, and then we have got here C5, okay, C5. Let me check other. Okay, this is C7, this is C8, this is C3. I think okay, this is C6. We have many cross section, and it's not okay that we have this much cross sections, although the accuracy would be high.